Okay, grade 11s, we've been talking so much about hydrocarbons, hydrogen and carbon only in a molecule, that it's time to take a look at what happens if we add something else onto an organic structure. Is it still organic? The answer is yes. Today we're going to take a look at what happens when we pluck off one of the hydrogens and replace it with a halogen. Remember the halogens, chlorine, bromine, iodine, fluorine, astatine? These all come from group 7 on your periodic table. And they will come and attach themselves, making a single bond in place of a hydrogen. Now, hydrogen, remember, has only one valence electron, so it has room to bond to a carbon molecule at one of carbon's 4 single electrons. We have a single bond there. But we could also have halogens come and attach themselves. Remember, halogens have 7 valence electrons, being in group 7. So, for example, if I was looking at chlorine, it would have 1, 2, 3, 4, 5, 6, 7 electrons. You'll notice in both of these examples that I have given, we have a shared pair here, a shared pair here. This could also be written like this. And of course, I would have to put hydrogens on both sides of this in these 2 spots to make up the remaining unbonded pairs. So halogens, just like hydrogen, can make a single bond to a carbon. Because there are pairs of electrons around the remainder of the halogen, they are not capable of making any more bonds to any other molecules. How do I name them? Well, this is some of the easiest ones for us to do as the first of our derivatives. Because what we do is we just change the name ending to O. When we have chlorine attached to a hydrocarbon branch, regardless of the type of hydrocarbon, we name it as a branch, but we name it as a special kind of branch. We're going to take off the name ending "ene" and change it to O. So on this parent chain, if I grab my highlighter, you can see we have a 3-carbon parent chain. My parent chain is propane. 3 carbons with single bonds, propane. I have a chlorine branch. So my chlorine branch becomes chloro. I have to say where that branch is. And this branch is on carbon 1 of my propane chain. So now that I have the opportunity to put a different kind of branch on, I'm going to be restricted to only using alphabetical order for naming multiple branches. In these 3 examples, I have methane being my parent chain. My branch is the chlorine, so it's chloromethane. In this case, I'm allowed to not say 1 chloromethane, only because there's only one place to put the chlorine, and of course it has to be on carbon 1. In this next example, the longest chain is 3 carbons with single bonds. It is propane. But there are 2 branches. There is a methyl branch and a bromo branch. Alphabetical order has to rule. So I must name my bromo before I name my methyl in the name. Both branches get their own number. So this is 2-bromo, 2-methylpropane. In this last example, I've got a 2-carbon chain, but there's a double bond. It is ethene. On my ethene is a single branch. It is a chloro branch. Again, in this case, I was able to not write 1 chloroethene because, of course, there is no other place to put it except 1. Although, in any case like this, if you're not sure if it's safe to drop the number, don't. It is never wrong to include a number, but it can be wrong to drop one. So it is important that we have them. For example, if I were to make ethene and have 2 chlorines, 1 here and 1 here, in this case you must call it 1,1-dichloroethene. You have to have, oh, not a dash there. You have to have both branches with a number, and you must say that they're both a number 1. The reason for that is because it was also possible that I could have made 1,2-dichloroethene. In these cases, because there's more than one place to put the branch, you would have to say where you put them. So when in doubt, include a number for every branch. Now, my halocarbons fall into 2 basic categories. There's the alkyl halides, when my halocarbon is attached to any kind of alkane, alkene, alkyne. There's also the aryl halides, which is what I call it if my halocarbon is attached to a benzene ring. There's nothing really that changes. We follow the exact same naming rules. So in this case, we have 2 carbons. It is F. It is single bond, so it is ane. And my chlorine is my branch, so it is chloro on ethane. And again, we don't have to have the number, but just to be safe, let's put it in. On this bottom example, we have my chlorine attached to a benzene ring. Again, my parent chain is benzene. My branch is chloro. And again, because there's only one branch by default, it's on carbon 1, but when in doubt, include a number for everybody. There are more examples for you to try on page 788 of your textbook. Now, alkanes, especially when we react them with halogens, which are usually diatomic, can cause substitution reactions. We can also do addition reactions. I leave this here for you to show you how we can substitute or add alkanes with halogens to make halocarbons. There's a whole series of reactions we can do in organic chemistry, but due to time constraints, we're just going to focus on naming the molecules and drawing the molecules. Here's another substitution reaction where we reacted a halocarbon with a base. So whenever you see an example of R just means the rest of the chain. In this case, it was a 1-carbon parent chain, and the X was the halogen. In this example, I used iodine. The base I reacted it with was potassium hydroxide. So this is a way we could make alcohols, which we'll get into in our next lesson. But again, for now, all I want us to focus on is naming and drawing aliphatic hydrocarbons and aromatic hydrocarbons that have branches that are halogens. So in your workbook on pages 40, 41, and 42, there are 3 worksheets where you can practice everything we've done with naming alkanes, alkenes, alkynes, and aromatics, but in these 3 pages, they all have halocarbon branches.